All right, this is your stats sensei, and this will be the third problem for the FRQ test. A drug company currently sells a prescription pain reliever that has been shown to be effective at lowering arthritis pain. However, since the drug also causes stomach irritation in some patients, the company has created a new formula that it hopes will reduce that side effect. So we're hoping to reduce the amount of stomach irritation. So we want the new formula to have less than the current formula, or the current to have more than the new formula. To see if the new formula reduces the occurrence of stomach irritation to users of the pain reliever, the company conducted a small preliminary study to conduct a new formulation with the current. In the preliminary study, 100 subjects with arthritis were randomly assigned. This is important. So this is actually an experiment. We always need to make sure we say random assignment if we were given our conditions, to take the current pain reliever, and 50 were assigned to take the new formulation. Patient responses at the end of the study are summarized below. Do the data from the preliminary study indicate at the 10% level? So here's our alpha. Oops. So alpha in this case is 10%. That the new formulation helps reduce the proportion of patients with stomach irritation compared to the current. The conditions for inference have been checked and verified. All right, so we didn't have to do the conditions on this one. If we had, we would need to make sure that we said random assignment, not random sample. Random assignment is different. This also lets us know that this was an experiment. So our null hypothesis, P1 equals P2. The amount of stomach irritation is the same. P1, the proportion is greater for P1 than it is for P2. P1 being the proportion of stomach irritation using current. P2 is the proportion using the new. So the proportion of current is greater than the proportion of the new. All right, so we need to show how we get our P hat 1 and P hat 2, and this is going to be a two proportion Z test. So 21 out of 42, I mean, it's 21, excuse me, I said that wrong. 21 out of 50, so 21 over the 50 gives us 0.42. And for the new formulation is 17 out of the 50. We had the same sample size, which is interesting. And we need to make sure that we show how we pool. So we have to include this part. We have to show this work. So 21 plus 17 and 50 plus 50, and that gives us 0.38. So this is our pooled. And we'll go ahead and plug into our formula. And you had to have these values. So the 0.42 came from here, the 0.34 came from that. And then the 0.38 here, and the one minus 0.38 is 0.62. And they both happen to be over 50. So in this case, that ended up being exactly the same. All right. So when we go ahead and start looking at this, we need to go, let's run the test. So we're going to go stat test, two proportion Z test, 21 over 50. And the other one was 17 over 50. We set it up with a greater than. We do a calculate. And we end up getting 0.2049. And we always have to include our Z-score, which is 0.824. So we need to make sure we have this and this. So there's our p-value. It's a pretty big p-value, and it's greater than 0.10, so we fail to reject the null. All right, just so you know, this very top part, stating the null and alternative, defining the parameters, and getting the correct p-value, all of that was worth 1 point. Then the conclusion was our p-value is 0.2049. We failed to reject the null. There is not sufficient evidence at alpha equal 0.01 to suggest a true population proportion of patients with stomach irritation using the current drug is greater than that of those using the new drug. All right. So relative to the current drug, we cannot say that the new drug decreases the amount of stomach irritation. This study does not say that we have enough evidence. And this right here, your conclusion was worth another point. So there's 2 points. And then it says part B says, based on your conclusion in part A, which type of error, type 1 or type 2, is possible? Describe the consequences of each error. And basically, we changed that on your test so that you only had to do it for describe consequences of the error. So we failed to reject the null, and the only type of error that we could have committed was a type 2. So we explained what type of error and the consequence. In this case, a type 2 error would be believing that the current drug and new drug have similar rates of stomach irritation, when in fact the new drug has a lower rate of stomach irritation. Because what happens is we believe this, but this was actually true. So we believe that they had the same rates, but really the new drug had a smaller stomach irritation. The consequence is that the pharmaceutical company would not develop the new drug that would help decrease this rate of stomach irritation among arthritis patients. We did not need to include this. We just had this for our grading rubric if in fact you chose the wrong one, so we could sit there and look at it. Okay, so getting this part right will get you another point, so that's 3 points. And then the 4th point was a difficult one. I'm going to leave it here for just a second. So it says, after the preliminary study, one of the researchers of the company suggested that the procedure described above would have more statistical power if the sample size was increased, and recommended that a simulation study be conducted to investigate that more completely. For the purposes of the simulation, the researcher assumed that 40% of the patients in the current pain reliever will have stomach irritation and only 30% in the new. So basically, the assumption is 30% new, 40% current. Further, the total sample size will now be 200, with 100 subjects randomly assigned to each treatment. 100 trials of the simulation were conducted, and a p-value was calculated for each trial based on the testing procedure. Significance level and hypothesis used in part A, a histogram of the p-values is given below. Use the information in the histogram to estimate the power of the test if the test is performed at the 0.1 level. So they're telling us that alpha equals 0.10, and we have our list of p-values here. All right. Well, our initial claim was the proportions were equal, and our alternative was the current had less, that the current had more irritation than the new. All right. Now we reject if our p-value is less than alpha. That's when we reject. P-value is less than alpha, we reject. Well, that means we need to be less than 0.10. So to reject, this is what we needed to be right here. All right. Out here it would be failure to reject. Well, since we know that we have less stomach irritation, we should be rejecting. All right. Because power is the probability of correctly rejecting a false null, which is what I say right here. We only reject a null when our p-value is less than alpha. In this case, our p-value must be less than 0.10. So our p-value has to be less than 0.10. Based on the researcher, we know that the null should be rejected because the proportion of people developing stomach is 0.4, and the new study is only 0.3. All right. So yeah, this is definitely less, so we should be rejecting. And then here's the way you actually work the problem. We know this is the rejection zone. The current graph of the simulation indicates our p-value is less than 0.1, or less than alpha of 0.1, 60 times. And that comes from this being about 45 and this being about 15. Now, you can't read those numbers exactly, so you're going to have some rounding differences. So that would mean 60 of the 100 trials, or 60%, rejected the null. All right? So in this case, the power of the test is 60 over 100, or 0.6. It was also correct to sit there and add up all these values, because that's when you didn't. And power equals 1 minus beta. This is when you failed to reject, and you should have been rejecting, and you should have gotten 1 minus 0.40. Now, there'll be, like I said, these are very hard to read, so there is a fair amount of flexibility if work was shown. So quite frankly, either way was going to get that. And I had people getting it from 1 minus beta, and I had people getting it from using the 45 and the 15. Difficult question, worth 1 point, which isn't a big deal, because really, if you got this wrong, you could still make 101 on the test. So in this case, we will correctly reject the null that the two medications have equal occurrence of stomach irritation in favor of the alternative. All right, so they'll do that 60% of the time, and they'll do that, and they're, like I said, they want to reject, and they should be rejecting, because the new is 0.3, which is actually less than the current. All right, so once again, power is the probability of correctly rejecting the null, and this was a more challenging problem. All right, thank you for watching, and make sure you get these all written up and turned in.